Hey guys, Elmer the Exponential Elephant here talking to you about zero and negative exponents. Here's a question. What do you call an elephant that doesn't matter? Irrelevant.
First thing we're going to talk about are exponents. Exponents, if you recall, it's something raised to a power. Now that something is called your base, and that power is called your exponent. And the exponent tells you how many times to multiply the base by itself. So here we have 4 to the third power. Now 4 to the third power just means you're going to take 4 and multiply it by itself 3 times. So 4 times 4 times 4. Now how do we do that? Well, 4 times 4 we know is 16, and then 16 times 4 is 64. So that's how you do that.
If you took away an elephant's trunk, how would it smell? It still smelled pretty bad. Example time.
So example 1 says simplify each expression. So here we have 8 to the second power. That means we're going to multiply 8 times itself twice. So 8 times 8, that's going to give you 64. For part B, we have 5 to the fourth power. Now that is telling you to multiply 5 by itself 4 times. So 5 times 5 is going to give you 25. And then 25 times 5 is going to give you 125. Then 125 times 5 gives you 625. Part C, we have 2 to the seventh power. Again, multiplying 2 by itself 7 times. If you want to know how to do that, you just go 2 times 2, that gives you 4. And then 4 times 2 gives you 8. And then 8 times 2 gives you 16. And then 16 times 2 gives you 32. 32 times 2 gives you 64. And then 64 times 2 gives you 128. Lastly, we have 4 to the first power. That's multiplying 4 by itself 1 time. So it's just 4, and you're done. Now, zero exponents. Any non-zero number raised to the zero power is always equal to 1. So here you can see we have 8 to the zero power is equal to 1, 100 to the zero power is equal to 1, negative 5 with parentheses around the negative 5 raised to the zero power equals 1, negative 4/5, again, parentheses around the negative 4/5 raised to the zero power is going to be equal to 1. Now notice the parentheses, I pointed those out because that makes a difference. Here, because there's parentheses around the negative 5, we're raising that whole number to the zero power. That's going to equal 1. Here, what's actually going to happen is you're going to use the order of operations, which means you have to do the exponent first and then tack on this negative that's out front. So it would be 5 to the zero power would equal 1 times that negative 1 that's out here, and that would give you negative 1 as your answer. Same thing here. Since the negative is outside the parentheses here, we would raise the 4/5 to the zero power. That would give you 1, and then you would tack on the negative to make it negative 1. Also, please note that 0 to the zero power is undefined. It's not equal to 0. That's why it says any non-zero number raised to the zero power. Example 2 says simplify each expression. So 20 to the zero power, that's 1. Any non-zero number raised to the zero power is equal to 1. Same thing here. Negative 0.5 raised to the zero power equals 1. If we have negative and then parentheses 1/3 raised to the zero power. Now we talked about this. Because the negative is on the outside of the parentheses, what we're going to do is we're going to take 1/3. We're going to raise that to the zero power, which equals 1. And then we're going to tack on the negative. So that actually equals negative 1. Next, we have w to the zero power. Now, we're going to assume w is not equal to 0. It's some number not equal to 0. So w raised to the zero power is still going to equal 1.
How do elephants keep cool? Air conditioning. You try.
Okay, doing the same thing here. So we have negative 10 raised to the zero power. Now notice there are no parentheses around the negative 10, which means we're going to take the 10, raise it to the zero power, and then tack on this negative. So it's actually going to be equal to 10 to the zero power is 1 times that negative out front is going to be negative 1. 4.3, it's a non-zero number raised to the zero power. That's going to equal 1. Same thing here. We have parentheses around the negative 5/9, which means we're going to take this number, raise it to the zero power. That's going to be equal to 1. Here, we have 8 times x to the zero power. Now notice, there are no parentheses around the 8x, which means x is the only thing being raised to the zero power. Now, if we assume that x is a non-zero number, what we're going to do then is we're going to say, okay, x to the zero power is going to be equal to 1. And then I take that 1 and multiply it by the 8, and I get 8 as my answer. Now let's talk about negative exponents. So here, we're going to fill in this table right here. Let's start in the middle. Since we just talked about zero exponents, 2 to the zero power we know is going to be equal to 1. 2 to the first power is just 2 times itself 1 time, so that's 2. What if we talk about 2 to the negative first power? 2 to the negative first power is actually equal to 1/2. 2 squared. 2 squared, that means 2 times itself 2 times. 2 times 2, that equals 4. Well, what does 2 to the negative 2 equal? Well, that actually equals 1/4. And then 2 to the third power, that's 2 times 2 times 2, which equals 8. But what does 2 to the negative third equal? 1/8. Now, can you see a pattern with what's happening with our negative exponents? What does a negative exponent do? Well, it actually evaluates that base at that exponent and then flips that fraction. So 2 to the first equals 2. 2 to the negative first equals 1/2. 2 to the second equals 4. 2 to the negative 2 equals 1/4. And 2 to the third equals 8, which means 2 to the negative third equals 1/8. So we see that negative exponents actually require you to flip that fraction, or take whatever your base is and move it to the opposite side of the fraction bar. So yeah, negative exponents require you to move the base and the negative exponent to the opposite side of the fraction, and that will turn your exponent positive. So here you can see 2 to the negative fourth. The way you evaluate this is you say, okay, I'm going to take that 2 to the negative fourth and we're going to move it to the denominator where the exponent now becomes positive. And I can evaluate this. So instead of 2 to the negative fourth, it's 1/2 to the positive fourth. And 2 to the positive fourth is 2 times itself 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's going to be 1/16. Now let's practice this. Example 3, we're going to simplify this expression, 20 to the negative first power. When I evaluate this, again, I'm going to take 20 to the negative first and I'm going to move it to the opposite side of the fraction bar. So it's going to be 1/20 to the first power. Now 20 to the first power, I just multiply 20 by itself one time, so it's just 20. So my answer is going to be 1/20. Let's try this again. So -2 to the negative third power. What I'm going to do is I'm going to take -2 and I'm going to move it to the opposite side of the fraction bar and make the exponent positive. So it's going to be 1/2 to the positive third power. Now, I'm going to take -2 and multiply it by itself 3 times. So -2 times -2 is +4. Times -2 is -8. So that's why your answer is -1/8. Please make sure you know that the negative exponent does not affect whether this answer is positive or negative. That's this guy right here. Okay, part C, we have 3/4 to the negative second power. Again, a negative exponent does not affect whether your answer is positive or negative. The negative exponent just tells you to flip your fraction. So what you could already do, make this fraction 4/3 and this a +2 exponent. Or if you want to break it down to show why that's the case, if you have a fraction raised to an exponent, you can actually make that exponent the exponent of your numerator and your denominator. So it looks like this. Again, 3 to the negative second power. To make it a positive exponent, I have to move it to the opposite side of the fraction bar. So this is going to come down here and become 3 to the +2. This 4 to the -2, since it's in the denominator, I have to move it to the opposite side of the fraction bar. So it comes up and becomes 4 to the +2 in the numerator. Now all you have to do is do 4 squared, which is 4 times 4. That's 16. In the denominator, I have 3 times 3, which is 9. So 16/9 is my answer. Here, I have a to the negative second times b to the fourth all over c to the third times d to the negative fifth. Again, anything with a negative exponent has to move. Your answer can't have a negative exponent in. So what I do is I take this a to the negative second, just this a to the negative second, and I move it to the denominator, the opposite side of the fraction bar, and it becomes a +2 exponent. Here, this d to the negative fifth, I'm going to move it to the numerator, the opposite side of the fraction bar, and it becomes a +5th exponent. And you're done. Anything with already a positive exponent can just stay where it is.
What's the difference between a mouse and an elephant? About a ton. You try.
Okay, -4 to the negative first power. Again, the negative exponent just tells you to flip your fraction or move your base to the opposite side of the fraction bar. So -4 to the negative first power is the same as 1/-4 to the positive first power. Now, -4 to the first power is just -4, so your answer should be -1/4. Here we have 10x to the negative third. Notice there are no parentheses around the 10x, which means x is the only thing being raised to the negative third power. So what I do to make sure my answer doesn't have a negative exponent, I take this x to the negative third power and I flip it. So it becomes 1 over x to the positive third power. Now when I multiply that by 10, the 10 just goes to the numerator, so I get 10 over x to the third power. Here I have negative 1/5 raised to the negative fourth power. What I'm going to do is I'm going to take this negative 1/5, and you could right away know that, okay, I just have to flip this fraction and it becomes a positive fourth power. So it would be negative 5 over 1 to the positive fourth. Or you could apply this negative fourth exponent to the numerator and denominator. When you do that, this negative right here can go with the numerator or the denominator. It doesn't matter. You'll get the same answer either way, but it can only go with one of them. You can't have a negative in the numerator and denominator because then that would be positive. So you take this negative, apply it to the numerator or denominator. I moved it to the numerator, so it's negative 1 to the negative fourth power over positive 5 to the negative fourth power. Now, again, negative exponents, you move it to the opposite side of the fraction bar to make your exponent positive. So we move each of these to the opposite side of the fraction bar and the exponents become positive. 5 to the fourth power, that's 5 multiplied by itself 4 times. I think we did that before. 5 times 5 is 25, times 5 is 125, times 5 is 625. In the denominator, negative 1 times negative 1 is positive 1, times negative 1 is negative 1, times negative 1 is positive 1. So negative 1 to the fourth power is actually positive 1. So my answer is 625 over 1, which is just 625. Lastly here, again, anything with a negative exponent has to move to the opposite side of the fraction bar in order to become a positive exponent. So x to the negative 7th power, I move to the denominator and it becomes x to the positive 7th. Q to the negative 8, I move to the numerator and becomes q to the positive 8. And then z to the negative 2nd, I move to the numerator and becomes z to the positive 2nd. And you're done. Now our word problem says, when studying a group of black widow spiders, you find that the population doubles every week. The expression 1,000 times 2 to the w power models an initial population of 1,000 spiders after w weeks of growth. What was the population 3 weeks ago? What you want to do first when you have a word problem is not be scared, okay? We can do this. First thing you want to do, define our variables. We start with, what is the problem asking? What are we trying to find? Well, it says, what was the population 3 weeks ago? So we're trying to find the population. So we'll say P is the population of black widow spiders. Now, if you notice in the problem, it also gives you another variable, W. W represents weeks of growth. So we have 2 variables. Now what we can do is set up an equation. Let's write our equation. Well, again, the good news, they already give that to you in the problem. This happens a lot. We have the expression 1,000 times 2 to the w, and that models an initial population of 100 spiders after w weeks of growth. So the population, P, is going to be equal to 1,000 times 2 to the w. Now, the issue is we want to find the population 3 weeks ago. That's in the past. So I think if we plugged in 3 for W, that would give us the population 3 weeks from now. So if I want 3 weeks ago, what I'm going to do is plug in negative 3 for our W. Now what we can do is evaluate this. So to evaluate this, because we need to do order of operations, so we do exponents before multiplication. So we do 2 to the negative 3rd power. Now, when we want to make this a positive exponent, we take 2 to the negative 3rd, move it to the denominator, so it becomes 1 over 2 to the positive 3rd power. Now, 2 to the 3rd power, we know is 2 times itself 3 times, so that's going to be 2 times 2 is 4, times 2 is 8. So we have 1/8 that we're going to multiply by 1,000. 1,000 times 1/8 is the same as 1,000 divided by 8, which is just 125. Please don't just write 125 and put a box around it. You need to answer in a sentence. What was the population 3 weeks ago? The population was 125 spiders 3 weeks ago. And you're done.